We're going to continue on in section 11.1. So the first type of frequency distribution we're going to talk about is the categorical frequency distribution. And so that's when I have data that I can naturally put into categories and look at. So my first one, so my example of a categorical frequency distribution is a health food store recorded the number of vitamin pills 35 customers purchased during a one-day sale. The data is in the table below. Construct a frequency distribution for the data. So what we're going to do is we're going to put in our different kinds of vitamins. So we're going to say A, B, C, D, and E. And then we're going to put our frequency next to it. And so I'm going to put my frequency right here. And so I've got the vitamin type and then I've got the frequency. And then I'm just going to tally the information in. So I've got 1, 2, 3 C's. So I'm going to say 1, 2, 3. I'm going to put some lines in here so I can keep myself organized. And so then I've got an A and a D, an A and a D, an E and another C. A, D, E, C. Then I've got 2 more E's, another A, a B, a D, a C, and another E. So that's that whole next row. Then I've got C, E, C, 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 D, and an A. So that's my next row. Fourth row down, I've got 2 B's, a C and a C, an A and an A, an E. So that's the next row. I'm just going to put a line through them all. And then I've got 3 more E's, 1, 2, 3, an A, a B, a C, and a B. And so I've taken them and I've tallied them into this frequency distribution so that we can see that there's 6 A's, that there's 5 B's, that there's 12 if my tick marks are right. There's 12 C's, there's 3 D's, and then there's 9 E's. So we can see that the best seller is the C's, right? So we can see by this distribution, because we took the time to tally it into categories, we can at least have some kind of discussion about it. We can say that the vitamin D's weren't selling very well, so either the sale wasn't steep enough or people aren't using vitamin D. The vitamin C's, there's 12 occurrences of that, and so during my one-day sale, I sold a lot of C's, so maybe that would tell me what to purchase in terms of these vitamins to get ready for maybe my next sale. So I collected the raw data, and so I just said, oh, what am I selling during this one-day sale? And then I turned around and built a frequency distribution of those categories. So the second type is a grouped frequency distribution. So these are ones that don't naturally fall into groups, and it's because you're using numerical data. So maybe you're looking at temperature, maybe you're looking at weight, maybe you're looking at speed. And so you've got some numerical data, but you're trying to group them together instead of just having a pile of data. So this is called a group frequency distribution. So we've got this example. And so some of the basic guidelines are, we want to try to keep the number of classes, the number of groups that we're putting them into between 5 and 15. So we don't want to have 2 groups and we don't want to have 50 groups. So we want to try to stay between 5 and 15. That's an industry standard. We want to make sure that the classes don't overlap. So we don't want to go from 0 to 12 degrees and then from 10 to 20 degrees, because then we've got a 2-degree overlap. We don't want to leave out any numbers between the low and the high. And we want to make sure that the range of the numbers included is the same for each one. So if we're going with 10 units, everything needs to be 10 units. We don't want one group to have 10, the other group to have 5, the other group to have 7. So all of the groups have the same width. So here's an example. So here I've got the record high temperatures for each of the 50 states in Fahrenheit. And so I want to do a grouped frequency distribution. And so I want to try to group this instead of just handing somebody 50 pieces of data. And so I want to start with the low and go to the high, and I want to try to do this grouped frequency distribution. So the first thing that I want to do is I want to subtract the lowest value from the highest value. And so I want to look through my data, and I want to say that I've got the lowest value being here at 100 degrees, and then I have the highest value being here at 134. So I want to take the high minus the low, so I've got 34 degrees in that temperature difference, and then I want to divide it into classes. And so in this one's case, I decided that I wanted to have 1, 2, 3, 4, 5, 6, 7 classes. So I started with the 100. I'm going to take that value, that 34, and I'm going to divide it by 7. And then I'm going to round up. And when I round up, I get 6. So I want to start with I want to go from 100 to 105 as I get the class limits. So as you're doing this, you want to always start. So because I wanted to come up with I'm going to correct myself, not 6, but 5. So because I want these things to have units of 5, I want to always go down adding 5 in each one of these cases. So I'm going to say plus 5, plus 5. So build this column first: 100, 105, 110, 115, 120, 125, 130. So I want to go down that list. And so remember, I got that from taking the high minus the low, the 34 degrees, and dividing it by 7, because I wanted 7 classes. Okay, so I get 4 point, and then I'm going to round it up to a whole number. So when you do this division, you want to start with 34 divided by 7. Then when you get that number, I want to round it up, and that's how I got that 5. So then I start with the lower class limits. Then to get the upper class limits, I just subtract 1. So when I did this one, I had the 105 and I just went back 1 and got 104. I took 110 and I went back 1 to get 109. Back 1 to get 114. So to get the stopping point of the class, I just took the next class down and subtracted 1. So now I have a class. So now I have a range. So I'm going to tally, just like we tallied with the vitamins, I'm going to go through my 50 different temperatures, and I'm going to, tally them in to where they belong. So I have a group that goes from 100 to 104. I have a group that goes 105 to 109. So I'm going to tally those in to each one of those different classes that I did. So as I go through, I'm going to take these numbers, and I usually cross them out. So as I go through them, I would say 112, and then that would get tally marked into this class. Then I do 100, and it gets tally marked into this class. Just like we did the vitamins, I'm going to tick mark them in. So I'm going to say 127 goes into this class. 120 goes into this class. So when I finished, this is the tick marks that I got when I did all 50 states. So the only difference between these two columns, so I've got tally here, so that's just the mechanism that as I'm going through these numbers and crossing them off, I'm tallying them into the class. Then when I do the tallying, then I'm going to count my tick marks, and I'm going to call that my frequency. So these are one and the same. One of them I just got because I tallied my numbers in, and then the other one is just a recap of what I found. And so we can see from this frequency distribution that the most number of states had between 110 and 114 degrees as their record high temperature. And then we've got these two low ones down here, with one apiece. And we've got, two low ones on this end from the 100 to the 104. But what's kind of interesting in this is it's pretty bell-shaped. So it's going to come down here, it's going to have a mound, and then it's going to go this way. And so if I look at this thing, if I look at this shape of these tally marks on side, it looks like a bell-shaped curve. So if you turned it sideways, that would look like a bell-shaped curve, with the majority of the data being there in the middle. So it just was a naturally occurring bell-shaped curve. So the last thing that we want to talk about is we want to talk about the stem and leaf. So stem and leaf is a lot of times an exploratory data analysis. It's a quick thing to do to look at your data. And so what happens is when you have stems and leaves, the leaf is always a single digit. So you're always going to split it so that the leaf is one digit and the stem is whatever number. So in the case of 72, the 7 is the stem and the 2 is the leaf. If I have a 3-digit number, your leaf is always 1. So 13 is my stem, 8 is my leaf. If I had something like 0.1729, the 172 is my stem and the 9 is my leaf. So that's what you want to do all the time when you're doing these stem and leaf plots. So here's an example. So I've got the price of a gallon of gas and I'm going to draw a stem and leaf. And so I have to look at these and I have to decide, I want to trim off the stem on all of these, right? So I want to see what my values are doing. And so I've got 8 being my low number, and then I'm going all the way up to 12 being my high when I split my stems from my leaves. So when I'm doing this data, I'm going to start with the 8 because we said that was that low number, and we're going to go all the way up to the 13s, which is that 131, which is my high. So I'm going like this between these two values. So as I go through, I'm going to say 119, 119. Let me see if I can squeeze these in here in this table the best I can. So that's a 9. So that's my 119. And then I say 131, 122, 113, 112, 86. So the 6 goes here. 90, so that gets a 0. Another 90 gets a 0. 100 gets a 0 in this spot. 115, 114, 113, 111, 111, 115, 123 goes in this one. 123 goes in this one. 106, so 6 goes in here, and 117. So notice how I've got all these little leaves in here and there's no commas in between. So that's the one thing, is because everything's just a leaf, everybody understands that there's only one digit that represents those numbers, so you never have to put a comma. So don't put a comma on any of these, and then we want to leave some kind of a key to tell somebody what this means. So we'd say 119 equals 119 cents. And we want to say that because maybe the number is 11.9, or maybe the number means 0.119. And so we're going to give somebody like a key or a legend to tell them what's going on with the stem and the leaf. So stem and leaves, you leave all of the numbers in there and you just list them, and you never put columns in, and you always include a legend to tell people what your information means. Okay, that's the end of 11.1.